Hello everyone. Now our point of discussion is what is meant by intensive and extensive properties. Okay. First, let's consider an example. This is a beaker with 100 ml solution of 1 molar KMnO4. Okay, and now if we take 10 ml of this solution out of this container in small beaker, this is 10 ml same solution 1 molar KMnO4. Now we will study the macroscopic properties of this solution. How? First, take pressure on this KMnO4 solution at this particular point. The pressure will be, let's say, P1. Okay, and now the 10 ml solution out of this beaker have also pressure P1. It will not change. It will also have pressure P1. Now temperature T1, it will also have T1 temperature. Okay, temperature will also not change. Now let's say viscosity eta, it will also be constant. Now if we measure the weight of this beaker full of KMnO4 solution, we'll find it different. So it will be W1, but here weight will change, weight will be decreased, so W2. Okay, now accordingly mass will also change, M1, M2. Volume is different, we can see it. Yeah, volume V1 and here volume V2. Okay, and also energy can also be changed. This is energy E1. Here it is small, it is in small quantity, hence energy will also be very less, E2. But the melting point of, this is the liquid, so boiling point of this liquid will be same as of this, because the liquid is same, boiling point will not change, will not vary. Okay, so we can categorize these different macroscopic properties in two categories. Okay, first is intensive property and second is extensive property, depending upon whether the property is the value of property is getting changed by amount, changing the amount of the substance present in the system. So and this, the properties in this box are not changing with the amount, hence we can say these are independent of amount of substance, independent of amount. Hence what is meant by this property, then these properties are called as intensive properties, which are independent of the amount of substance present in the system. Which are those properties? Temperature, pressure, viscosity, resistance, refractive index. Sorry, resistance is not, this is density. Yeah, density will also remain same, mass upon volume. Density, mass upon volume. It is the ratio of two extensive properties. Mass is changing, volume is also changing, hence these both are extensive properties, and the ratio of these two extensive properties is density, which is intensive property. Okay, so surface tension, boiling point, melting point, these will not change with change in amount of substance, while in case of mass, weight, volume, energy, they will change with change in temperature, hence these are called as extensive properties. Okay, Now we know what are extensive and intensive properties, and how to remember whether the property is intensive or extensive. So intensive means independent, just remember this. Then you can distinguish extensive accordingly. Now, what is thermodynamic process? Thermodynamic process means changing of system from one state to another state, that is called as thermodynamic process. That change is called as thermodynamic process. Okay, these processes are categorized again in different categories. First is isothermal process. Okay, we have written here isothermal process. Here delta T is equals to 0. Change in temperature equals to 0 in case of isothermal process. Similarly, in adiabatic process, change in heat delta Q is equals to 0, while in isobaric process, bar means bar is the unit of pressure. So we can remember this, change in pressure is 0 in case of isobaric process. In isochoric process, change in volume equals to 0, while you can remember these four things. Okay, in isothermal, therm it denotes temperature, hence we can say in isothermal process delta T is equals to 0. Again, one thermodynamic process is called as cyclic process. If our system is at state A and it go to the state B, again from B it is coming to state A. Now this whole process is called cyclic process. That means initial and final state of the system is same. That process is called as cyclic process. Okay, this is all about thermodynamic processes. Now, what is reversible and irreversible process? In reversible process, what happens? In our process, we do the process in very infinitesimally small steps. Okay, very small steps are involved in reversible process. It is ideal case, ideal process. Okay, why it is ideal? Because we cannot have infinitesimally small step. Practically it is not possible, and if each small step is infinitesimally small, then the time taken to complete the process will also infinity, so it will take infinite time for completion. Therefore this process do not occur practically, but it is present only at only ideally we can predict this. Okay, and what about irreversible process? It do not take place in infinitesimally small amount, or it do not require infinity time. Okay, we can suppose compression of gas. This is compression of gas. In case of reversible process, see, this is piston. Okay, this gas container, ideally it should be frictionless. Piston should be frictionless, and here is gas. Now infinitesimally small amount of pressure we want to give on this, apply on this piston. So let's have example of very small minute sand particle. Okay, then this sand particle will apply very small amount of pressure. Likewise, if we drop one by one such many infinity sand particles, many more sand particles, then after so much time we will get some value of compression. This piston will be displaced, and this process require infinity amount of time. Okay, and in such a process, at any step we can reverse the process. Okay, if we have pressure P1, P2, P3, this series of steps where we are applying the pressure. If we are applying the pressure, first is P1, second is P2, third particle will apply P3, and if we want to reverse the process, we will just remove this P3 and we will get volume V2. Okay, that means we can regain the state dV. This change we can again revert. This process can occur backward, go in backward direction also. Such a process is called as reversible process. Now in irreversible process, what happens? The piston moves in single slot. There is no series of steps required and we can get the compression immediately. Such a process is irreversible process, but because why? There is loss of energy in the form of heat and other things. So whole energy lot is not utilized for work done itself. It is just there is some energy loss also. Therefore, the process cannot be reverted back. Okay, it cannot go in backward direction. This reversible and irreversible processes.